Samples of four metals A, B, C, and D were taken and added to the following solutions one by one. The results obtained have been tabulated as follows. Metal A reacts with iron sulfate and there's no reaction,
I'm
which
writing.
means it's less reactive than iron.
A added to iron sulfate, no reaction means A is less reactive than iron. Very good. Next,
But it displaces copper, so it's more reactive than copper.
copper sulfate solution reaction takes place. It means A is more reactive than copper. Very good. Next,
Uh, B displaces iron, it is more reactive than A.
B displaces iron. So it means B is more reactive than iron.
But it is less reactive than zinc.
But it is less reactive than zinc. Very good. Next, C is
C is less reactive than iron, copper, and zinc.
less reactive than iron, copper, and zinc.
And D has to be the least reactive because it's not even reacting with silver.
एक second. And C is more reactive than
Silver.
silver. ठीक. Next,
D is a least reactive metal.
D is less reactive than iron, less reactive than copper, less reactive than zinc, less reactive than silver. Now, which is the most reactive metal?
B.
We will prepare activity series. देखो, A and Fe. A is less reactive than Fe.
Yes.
A is more reactive than Cu. B is more reactive than Fe.
Yes.
B is less reactive than Zn. Correct?
Yes.
B is less reactive than Zn. C is less reactive than iron. Correct?
Yes.
C is less reactive than copper. C is less reactive than zinc. It means C will come here.
Yes.
And D is less reactive than iron. D is less reactive than copper. D is less reactive than zinc. D is less reactive than silver. Means D will come in the last.
Yes.
आ गए सब A, B, C, D. Now, which one is the most reactive metal?
B.
B. What would you observe if B is added to a solution of copper sulfate?
It would displace
Copper. Very good. Next, arrange the metals A, B, C, D in the order of decreasing activity.
B, A, C, D.
B, A, C, D. Very good. Next, question number 4.
Which gas is produced when dilute hydrochloric acid is added to a reactive metal? Hydrogen gas.
Very good.
Metal plus acid gives salt plus hydrogen
Metal plus acid
gas. Gives
gives.
salt plus hydrogen gas. Write a chemical reaction when iron reacts with dilute H2S.
Hmm. Give here proper reaction. Metal with acid gives salt and hydrogen gas. So any metal you can take here.
Mom, they said iron.
Uh, oh, so sorry. Iron plus H2SO4 gives FeSO4 plus H2.
Mom, here this is iron sulfate.
chemical. Yes.
The product number.
Yeah, it is salt, iron sulfate, hydrogen gas. Next, fifth.
What is the difference when they say ferrous sulfate and
Actually, iron sulfate we will take FeSO4. Ferrous sulfate, ferric sulfate means valency of iron. If it is ferrous, valency of iron is 2, sulfate also 2. So it will become FeSO4. If they are saying ferric sulfate, it means valency of iron is 3 and sulfate is 2. So it will become Fe2SO4 whole thrice.
what's the valency of iron?
Iron have two variable
2.
valencies, 2 and 3. If it is 2, then us. If it is having 3, then ik.
Okay.
Fifth,
What would you observe when zinc is added to a solution of iron sulfate?
here it is given 2, means we are taking valency of iron as 2.
Okay. Ma'am, it would displace it
Because
because
zinc
zinc is
is
more reactive than iron.
more reactive than iron. Very good. How do metals and non-metals react? Thania, as I already told you, metals form positive ions,
Yes, ma'am.
non-metals form negative ions. How metals form positive ion? Because metal donate electron. It has extra electron and it donate electron. Non-metal accept the electron. Okay.
Yes, ma'am.
Here we can see like sodium and chlorine. Sodium and chlorine. So, electronic configuration of sodium is 281 and chlorine
Yes.
is 287. So what will happen? Sodium will give 1 electron to chlorine. So sodium will become 28 and chloride will become 2, 8 and 8.
Mom, I understood this, but in the case of, I think they gave another example other than sodium and chlorine.
Hmm.
And
Magnesium, magnesium chloride.
yes, ma'am. I got confused when
Ma-
they wrote 288. I thought it's supposed to be 28. And
it's
can you explain that?
yes, yes, sure. Magnesium has 12 electrons, 282. 282
Yes, ma'am.
है ना, and chlorine 287. So magnesium has 2 electron at its outermost shell
Yes, ma'am.
and chlorine 7 electron. 1, 2, 3, 4, 5, 6, 7. So what will happen? 1 electron will go there, but
Yes, ma'am.
1 is still remaining extra. So another chlorine, 1, 2, 3, 4, 5, 6, 7, and 1 electron will go here. It means magnesium will have two positive charge, one on this chlorine. It means it will become MgCl2.
Ma'am, so like it has to form an octet.
Hmm? It
It can only take one electron because it should form an octet in its
yes,
last.
yes, yes. Only
Acha,
one.
so इसलिए I thought it has to be written as 289 and I got confused.
No, it should be 288. It should be 288, and it will become 28. It will become 28 because magnesium will give 2 electrons.
Yes, ma'am.
Chloride 287. It will give it 1 electron will be added here, and it will become MgCl2.
Ma'am, can we take the example of any other? I want to
Other.
practice this.
Sure, sure. I will take. Firstly, we will read, and after that, I will take.
Yes, ma'am.
Start to read.
How do metals and nonmetals react? In the above activities, you saw the reactions of metals with a number of reagents. Why do metals react in this manner? Let us recall what we have learnt about the electronic configuration of elements in class 9.
Hmm.
We learned that noble gases, which have a completely filled valence shell, show little chemical activity. We therefore explain the reactivity of elements as a tendency to attain a completely filled valence shell. Let us have a look at the electronic configuration of noble gases and some metals and nonmetals. We can see from table 3.3 that a sodium atom has one electron in its outermost shell. If it loses the electron from its M shell, then its L shell now becomes the outermost shell that has a stable octet. The nucleus of this atom still has 11 protons, but the number of electrons has become 10. So there is a net positive charge giving us a sodium cation Na+. I didn't understand this sentence.
Hmm. In structure of atom, in nucleus, neutron and proton, and we know number of proton is equal to number of electrons. Number of proton is equal to number of electrons.
Yes,
So
ma'am.
in here proton is 11, and
Always we take that number of electron number according to the atomic number, right?
yes, atomic number of proton, because in iron one electron will go here. देखो 2 8 1 2 3 4 5 6 7 8 2 8 1.
Yes,
So
ma'am.
when it will give one electron, so number of electrons here 10 means 10 negative charges, but number of proton will remain same, that is 11 means 11 positive charges. Hmm? So it
Yes.
means one extra positive charge, that's why Na will become positively charged ion.
Oh, okay. Only the electron in the.
Electron will be given, electron can be taken.
Wait, so the
Hmm?
all of them are electrons in every shell.
Electrons are,
In every shell, those are electrons.
yes. Only neutron and proton only in nucleus. Here
Oh, yes, ma'am.
in
Only the
every shell,
electrons
if
are there in the
ha
outer shells.
outer shell electrons only, name of shells like K, L, M, N, and having normal capacity means one electron has in in first shell only two electrons can be there, in
And the second, only eight.
eight electrons, and only in last one electron.
Ma'am, so the all the electrons in only the electron in the last shell gives a positive charge.
Ye- yes. No, वैसे no, electron is given to another element, so extra proton in the nucleus giving positive charge.
Oh, so it's already negative, but when it's about to be given to the
Then
another element,
due
that's
to
when
uh,
it gains a positive
due
charge.
to this extra proton there is one positive charge. Okay,
Okay.
this is the electronic configuration of some elements like noble gases means helium, neon, argon. These
Why
are
is
the
it called noble gases?
atomic number, and these are number of electrons in shells like K, L, M, N. Okay, so in helium 2 288 we can see octets are completed. In case of metals we can see like sodium, magnesium, aluminium, potassium, and calcium. Sodium is 11, so 281. Magnesium is 12, so 282. Aluminium is 13, 283. Potassium is 19, 2881. Calcium is 20, 2882. So here we have to observe one thing. In outermost shell like 1 2 3 electrons, 1 2 3 electrons, so that they can easily give. In case of non-metals, 7 2 5. 7 2 5 8 2 6 9 2 7. We can see here more than 4 electrons, so it is not possible for non-metals to give electron. So to complete their octet, what they will do, they will accept the electrons. And phosphorus, like 285, 286, 287. From here you can tell me the valency easily. What will be the valency of sodium? Because one extra electron, it will give one electron, so its valency will become 1. Valency of magnesium will become 2 because it will give 2 electron. Valency of aluminium will become 3. Valency of potassium will become 1. Calcium 2. The same thing, valency of nitrogen will become, how many electrons it will take?
How many electrons it will take or
Yeah.
how many electrons it will give?
No, we are discussing about non-metals. Non-metals
Achha,
will take, how many electrons will it take to complete the octet?
3,
3 electrons. How many electrons will it take to complete the octet?
2,
How many electrons will it take to complete the octet?
1,
How many electrons will it take to complete the octet?
3.
Only 1. So these are the valencies.
Achha, so for metals, it's based on
Gives
the number of electrons they'll give.
electron it will give. That's why metals form positive ions. Positive ions also known as cations, and cations are during the electrolysis process, cations goes towards the cathode. Non-metals form negatively charged ion, which is also known as anions. During the electrolysis process, they
They
goes
move
towards the
towards the anode because
anode
I positive
and
charge.
positive charge.
Ma'am,
Hmm.
I was going to ask something just a second.
Prisha,
Ma'am, then why do some metals have 2 or 3 different valencies, like for iron?
we will study about that. These are some transition metals and we will study about that in 11th standard. Means shells में अंदर अंदर ऐसा exchange होता है, okay, electrons का. But
Ma'am, so can you give me a few examples of those metals, like which have different valencies?
like iron,
Iron,
copper,
copper,
lead.
aluminium?
No, aluminium having 3
Only
only,
3.
3 only. Okay,
Yes, ma'am.
Prisha, is Prisha there?
She is, ma'am.
She is or not?
She is, ma'am, in the meeting.
Prisha, Prisha, can you hear me? Okay. Thanya, start to read from where?
Ma'am, we finished this paragraph. I'll read the last sentence again.
Okay.
The we can see from table 3.3 that sodium atom has one electron in its outermost shell.
Hmm.
If it loses the electron from its M shell, then its L shell now becomes the outermost shell and has a stable octet.
Hmm.
The nucleus of this atom still has 11 protons, but the number of electrons has become 10.
Hmm.
So there is a net positive charge giving us a sodium cation Na+.
Hmm.
On the other hand, chlorine has 7 electrons in its outermost shell
Hmm.
and it requires one more electron to complete its octet.
Hmm.
If sodium and chlorine were to react, the electron lost by sodium could be taken up by chlorine. After gaining an electron, the chlorine atom gets a unit negative charge because its nucleus has 17 protons and there are 18 electrons in its KLM shells.
Hmm.
This gives us a chloride anion Cl minus. So both these elements can have a give and take relation between them as follows.
Give and take. So here Na281, Na plus 28, sodium cation, chlorine 287, 1 electron, chloride anion 288, 1 electron will be given to chlorine Na plus Cl minus. So formation of sodium chloride, and these type of compound are known as ionic
Ionic
compound.
compound.
Why? Because They are formed by give and take of electrons. Complete electron to another one, or they are taking electron. Prisha, can you hear me? Prisha? Okay. Tanya, you continue.
Sodium and chloride ions, being oppositely charged, attract each other and are held by strong electrostatic forces of attraction to exist as sodium chloride. It should be noted that sodium chloride does not exist as molecules but aggregates of oppositely charged ions.
So what we got, that NaCl, sodium chloride does not exist as molecules, but they are having oppositely charged ions. Now formation
That
of
means they are attracted to each other.
attracted to each other, high attraction there, so they have strong forces between them, ions.
Yes, ma'am.
This is the formation of magnesium chloride. Let me know what we are doing here.
Ma'am, so we have written the electronic configuration of magnesium as 282 because its atomic number is 12. And then magnesium gives two electrons from its outermost shell.
Hmm.
And then uh, chlorine will receive one electron each because there are
Hmm.
two chloride anions.
So it will become Mg2 plus
Mg2 plus.
Cl minus Cl minus. And these are ionic compounds. So compounds formed by the transfer of electrons from a metal to a non-metal are known as ionic compounds. You have to note this down for your notes.
Yes, ma'am. Ma'am, it's Mg2 plus because it's receiving two net positive charges.
Two net positive charges. It
Okay.
can give two electrons. Properties of ionic compounds.
Should I read it?
Yes.
To learn about the properties of ionic compounds, let us perform the following activity.
Hmm.
Take samples of sodium chloride, potassium iodide, barium chloride, or any other salt from the science laboratory. What is the physical state of these salts? Take a small amount of a sample on a metal spatula and heat directly on the flame.
Hmm.
Repeat with other samples. What did you observe? Did these samples impart any color to the flame? Do these compounds melt? Try to dissolve the samples in water, petrol, and kerosene. Are they soluble? Make a circuit as shown in figure 3.8 and insert the electrodes into a solution of one salt. What did you observe? Test the other salt samples too in this manner. What is your inference about the nature of these compounds?
Hmm. So we have taken the samples of sodium chloride, potassium iodide, barium chloride, or any other salt from the science laboratory. Can you tell me the formulas of, like, sodium chloride is?
NaCl.
Potassium iodide?
Uh, K.
I.
Ki.
Barium chloride?
Valence. I'm trying to think. Ba.
BeCl2.
Only BaCl.
BeCl2. So a small amount of sample on metal spatula and heat directly on the flame. Repeat with other samples. What did you observe? Did the samples impart any color to flame? Do these compounds melt? Try to dissolve the sample in water, petrol, kerosene. Are they soluble? Circuit, insert the electrodes into the solution of one salt. What did you observe? Test the other salt samples to this manner. So here melting and boiling point is given. We can see very high. It is 1074 1686 Kelvin. This one is LiCl, means
Lithium chloride.
chloride, calcium chloride, calcium oxide, and magnesium chlorides. These are given. Melting and boiling point. So we will discuss about the physical properties of ionic compounds. So first one is physical nature. Physical nature means these are solids. Means these are solid, these are hard because strong force of attraction between the positive and negative ions.
Yes,
These are
ma'am.
hard, that's why these are brittle, break into pieces when pressure is applied. Melting and boiling point, we just read, it is very high because strong attraction between positive and negative ion. Solubility, these are electrovalent compound soluble in water because in water they gives iron but insoluble in solvent like kerosene and petrol. Conduction of electricity, when they are dipped in, they are means in water, they are soluble, they give iron, so they conduct electricity.
Ma'am, in the exam paper, they asked one question. They said, explain why ionic compounds. Ionic compounds have high melting and boiling points. Give reason. So
Hmm.
I did write that they require strong, large amount of energy to break the forces
Yes,
of attraction. But for some reason, I also mentioned electrostatic force.
yeah, it is correct.
It is correct.
It is
Okay.
correct, we have to. Actually, melting point, boiling point is high, it means they requires large energy to break the bonds. But why they need large energy, we
To
have to
break the
mention.
electrostatic force. So that word, it's correct. I
Correct.
thought they would cut marks or
No,
something
no,
because
no.
you mentioned
It
the
is
wrong.
correct. We have to give this reason also. Tanya,
Okay.
what you do is start to read from here. I told you all the points. After that, we will start discussion of
Okay.
questions. Huh.
You may have observed the following general properties for ionic compounds. Physical nature. Ionic compounds are solids and somewhat hard because of the strong force of attraction between the positive and negative ions. These compounds are generally brittle and break into pieces when pressure is applied. Melting and boiling points. Ionic compounds have high melting and boiling points. This is because a considerable amount of energy is required to bring the strong interionic attraction. Solubility. Electrovalent compounds are generally soluble in water and insoluble in solvents such as kerosene, petrol, etc. Conduction of electricity. The conduction of electricity through a solution involves the movement of charged particles. A solution of an ionic compound in water contains ions, which move to the opposite electrodes when electricity is passed through the solution. Ionic compounds in the solid state do not conduct electricity because movement of ions in the solid is not possible due to their rigid structure. But ionic compounds conduct electricity in the molten state. This is possible in the molten state since the electrostatic forces of attraction between the oppositely charged ions are overcome due to heat. Thus, the ions move freely and conduct electricity.
Electricity. Very good. Now, start to read this one. Write the electron dot structure of sodium, oxygen, and magnesium. Electron dot structure means you have to show valence electrons of sodium, oxygen, and magnesium.
So, I have to write it down now.
You can write it down. Firstly, let me know. Sodium.
Its valence is 11.
No, beta.
No?
Its valence is 1.
Sorry,
Having
I'm so sorry. Atomic number is 11.
atomic number is 11. At outermost shell, how many electrons?
It'll be 2, 1. 1.
1 electron. Oxygen,
Oxygen. Oxygen atomic number is 8,
hmm,
so it will be 2, comma 6.
6. So 6 electron at its outermost shell. Magnesium,
Its atomic number is 12, 282, 2 electrons.
2 electrons. Okay, this one is electron dot structures of sodium, oxygen, and magnesium. Show the formation of sodium oxide and magnesium oxide.
So, ma'am, we have to only show the electrons that it will give for.
Yes, 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 yes. Sodium oxide means how many sodium? Na2O. They have given the formula Na2O. 2 Na, 1 electron, 6 electron. So 1 electron from here and 1 electron from here. So Na will become 2 plus and O will become 2 minus. Okay.
Yes, ma'am.
Next one for MgO. How will you show? Let me know.
Mg. Ma'am, magnesium will give 2 electrons.
Hmm.
Ma'am, but this oxygen won't be 2. It'll take both the electrons here.
Yes, yes, yes. Magnesium has 2 electrons and both 2 electrons will be given to oxygen. So it will become
Because it has the space to take 2
2
electrons and
electrons.
formulate a slip.
What are the ions present in these compounds?
Like Na2 plus.
Na plus only, not 2 plus. Na plus, for 1 it is Na plus. You can say 2 Na plus ions. मतलब 2 Na plus ion है. Or
Okay.
otherwise you can simply write Na plus, O2 minus and Mg2 plus. Okay,
Because each Na is only giving one.
1
So
electron.
it's like, okay.
That's fine. Now you got till here all the things.
Yes, ma'am.
Now
Ma'am,
occurrence.
what exactly is the molten state?
पिघली हुई अवस्था. Molten state means when solid melts.
So liquid only basically.
Molten state actually, liquid means completely water type. Molten state like when solid melts.
Okay, yeah, based
The
on
name,
different materials, it can be with different
ha,
consistency.
different consistency. Occurrence of metals. Yesterday we done reactivity series.
Yes, ma'am.
We have seen some metals are most reactive, some less, some very least reactive. According to that, metals are found in different stages at nature, which are highly reactive. We can get them in combined state. Which are
Yes, ma'am.
least reactive, they will not react with other. And the original state at which we get metal from the nature is known as ore. Okay, start to read from here.
Occurrence of metals.
Hmm.
The Earth's crust is the major source of metals. Seawater also contains some soluble salts such as sodium chloride, magnesium chloride, etc. The elements or compounds which occur naturally in the Earth's crust are known as minerals.
Hmm.
At some
You have to
places,
write these definitions.
ma'am, they asked definition in exam.
You have naturally in Earth's crust are known as minerals. Hmm.
Ma'am, the problem with this exam was I understood most of the concepts, but it was hard for me to memorize all both the chapters in like 3 4 days.
So,
So I'm still getting used to the weekly test syllabus being increased.
okay. So, Thanya, you have to practice more. Nothing
Yes,
else.
ma'am.
Start to read. At some
Because
place.
compared to last exam, I was having trouble with just learning the chemical reactions in acid bases chapter only.
Okay.
But now I found it a little easier than the previous exam to learn many of the reactions.
Okay.
But the problem is the way I write. It's not in understanding the concept. My problem is with the preparation.
With Tanya, you
My
have to
marks
give
going.
time and you have to do more practice.
Yes, ma'am.
Only this one have solution. Okay. At some places.
In exam, I forgot to mention compounds. I only wrote elements which occur naturally in Earth's crust and known as minerals.
Okay. Okay. Now observe your mistakes so that you can improve in next exam.
Yes, ma'am.
Hmm.
At some places, minerals contain a very high percentage of a particular metal, and the metal can be profitably extracted from it. These minerals are called
Ores.
ores.
So you have to write the definition of ores also. Minerals contain a very high percentage of a particular metal and the metal can be profitably extracted from it. These minerals are called ores. Now, extraction of metals.
You have learnt about the reactivity series of metals. Having this knowledge, you can easily understand how metal is extracted from its ore. Some metals are found in the Earth's crust in the free state. Some are found in the form of their compounds. The metals at the bottom of the activity series are the least
Least
reactive.
reactive. They are
They are often found in a free state.
state.
For example, gold, silver, platinum, and copper are found in the free state.
देखो
Copper and
here,
silver.
this one found in native state, free state, because these are least reactive.
Yes, ma'am, why is mercury not mentioned?
Mercury, it is
Because
in
it's liquid.
liquid state and they are not including mercury in this topic.
Okay,
Or we can say it is not in our syllabus. Actually, mercury is also extracted, but it is not in our syllabus.
okay, ma'am.
Hmm.
Copper and silver are also found in the combined states as their sulfide or oxide ores.
Hmm.
The metals at the top of the activity series, potassium, sodium, calcium, magnesium, and aluminium, are so reactive that they are never found in nature as free elements.
Hmm.
The metals in the middle of the activity series, zinc, iron, lead, etc., are moderately reactive.
Hmm.
They are found in the Earth's crust mainly as oxides, sulfides, or carbonates. You will find that the ores of many metals are oxides. This is because oxygen is a very reactive metal and is abundant on Earth.
Is abundant. This oxygen is very reactive metal. Ores of many metals are oxides because oxygen is very reactive metal and is very abundant on the earth. Hmm.
Thus, on the basis of reactivity, we can group the metals into the following three categories:
Hmm.
metals of low reactivity, metals of medium reactivity, and metals of high reactivity.
Hmm.
Different techniques are to be used for obtaining the metals falling in each category.
एक
7.
सेकंड तानिया, here it is given potassium, sodium, calcium, magnesium, aluminium. These are by electrolysis.
Yes, ma'am.
Zinc, iron, lead, copper. These are reduction. These are using reduction. Sorry, reduction using carbon, and silver and gold found in native state. Okay.
Yes.
So here it is the process which is given. Firstly, we will read it and after we will study it in detail. So this one, ore. Concentration of ore. Concentration of ore means impurity will be removed, it will be washed so that ore is more concentrated. Metals of high reactivity like sodium, potassium, electrolysis of molten ore. Molten, now you got, पिघली हुई अवस्था इसे बोलते हैं when solid is melted. It is pure metal. Metals of medium reactivity, so there are two things. They, we can get them in carbonate ore or also in sulfide ore. If it is in carbonate ore, then calcination, I will tell all the things in detail. Firstly we will read it, okay? And for
Yes.
sulfide ore it is roasting, and after both the process we will get oxide of metal. Then reduction to metal, oxide of metal, it is reduced by removing oxygen, and purification of metal. Now metals of low reactivity, for low reactivity we will get sulfide ore. After roasting we will get metal, and after refining we will get pure metal. Okay. Now first process, concentration of ore we done, like enrichment of ore, same thing. Read it.
Ores mined from the earth are usually contaminated with large amounts of impurities such as soil, sand, etc., called gangue.
एक
The
second,
air-
you have to write this definition also. Ores mined from the earth are usually combined. contaminated with large amounts of impurities such as soil, sand, etc., called gank.
Yes, the impurities must be removed from the ore prior to the extraction of the metal.
Hmm.
The processes used for removing the gangue from the ore are based on the differences between the physical or chemical properties of the gangue and the ore.
Hmm.
Different separation techniques are accordingly employed.
Here, metals low in activity series, mercury is also discussed here. You asked me,
Yes, ma'am.
start to read. You got this point? How ore, how its concentration take place means gangue, the impurities must be removed from the ore prior to extraction of metals. The process used for removing the gangue from the ore are based differences between the physical and chemical properties of the gangue and the ore, and different separation techniques are accordingly employed.
Yes, ma'am.
Extracting metals low in the activity series.
Metals low in the activity series are very unreactive. The oxides of these metals can be reduced to metals by heating alone.
Hmm.
For example, cinnabar is an ore of
You
mercury.
have to learn this. You can get this question as objective type cinnabar, that is HgS, sulfide ore of mercury.
Yes, ma'am. When it is heated in air, it is first converted into mercuric oxide.
Hmm.
Mercuric oxide is then reduced to mercury on further heating.
So mercuric oxide is then reduced to mercury on further heating. So mercury, this one is mercury oxide, oxygen. On heating it will give mercury oxide plus sulfur dioxide. This one is mercury sulfide. I think by mistake I told mercury oxide. And mercury oxide on further heating, oxygen is eliminated and we will get mercury.
Yes.
These are, this is the topic extracting metals low in the activity series. Next one is copper. So copper, which is found as Cu2s, copper sulfide in nature, can be obtained from its ore by just heating in air. Because copper sulfide, it is heated with air, we will get copper oxide and sulfur dioxide. Copper oxide, again with copper sulfide, we will get copper and sulfur dioxide. You have to learn these reactions, balanced chemical equations. Okay,
Yes.
now we'll discuss about the sample papers we were discussing yesterday. So we'll continue. So we have done till 27. I think 28 also we have done. Now we'll start from 29.
Dye is respiratory pigment needed in multicellular organisms with a large body size. Ma'am, because
Hmm.
the gaseous exchange cannot take place with diffusion alone. It would take a large amount of time. That's why we have respiratory pigments like hemoglobin present in the blood, which combine with oxygen and transport it to various parts of the body
Hmm.
fast.
But very good. Next, I will
Give reasons.
give you. You told me correctly, but still I will explain again. Diffusion pressure alone cannot take care of oxygen delivery to all parts of the body. Reason: to ensure that the air passage does not collapse. Next, there is sufficient time for oxygen to be absorbed and for the carbon dioxide to be released. Next, chest cavity becomes larger. Oh, sorry, I think I told you different answers for this one.
Yes, ma'am.
You
Rings
will
of
just
cartilage.
remember. Next. Rings of cartilage are present in the throat.
Ma'am, because ma'am, I forgot the term, but that
Collapse.
membrane is
To,
very. It's a thin membrane. It is very delicate to
delicate
ensure that
to
it does not collapse.
to ensure that air passage does not collapse. Next.
Lungs always contain a residual volume of air to compensate for the loss of air when we are exhaling.
Hmm. So, yeah, there is sufficient time for oxygen to be absorbed and for the carbon dioxide to be released. So, lungs always contain a residual volume of air. Third,
The diaphragm flattens and ribs are lifted up when we breathe in,
Hmm.
so
Because
that the lungs can expand
ch-
and have intake of oxygen.
हाँ, correct है, and it is given chest cavity becomes larger.
Yes.
Next.
Walls of alveoli contain an intensive network of blood vessels,
Hmm.
so that they can transport the oxygen to different parts of the body.
Because exchange of gases takes place in the alveoli.
Yes.
Very good. Next question. Define reflex action with the help of flow chart. Show the path of reflex action such as sneezing. Firstly, define reflex action.
A sudden or involuntary action controlled by the spinal cord in
Hmm.
case in a situation of emergency.
Huh. So here reflex action is a sudden, spontaneous or immediate action in response to the environment stimulus. Okay,
Yes.
we have to prepare flow chart for sneezing. Can you prepare it? Should I prepare for you?
Mom, can you prepare?
So here stimulus, here it is receptors. Receptor means nose,
Yes, ma'am.
then sensory neuron, after sensory neuron
Spinal cord.
spinal cord, that is relay neuron,
Yes, ma'am.
after that motor neuron. Are you getting?
Yes, ma'am.
Motor neuron, after that effector, effector, that is muscles, and after that response. Okay, so
Yes, ma'am.
stimulus, receptors, nose, sensory neuron, spinal cord, relay neuron, motor neuron, effector muscles, and response. Next, 31.
Study the diagram given below and answer the questions that follow.
Hmm.
Name the defective vision represented in the diagram. Give reason for your answer.
Hmm.
List two causes of this effect. With
Hmm.
the help of a diagram, show how this defective vision is corrected. Ma'am, the defective vision represented is myopia. Because
Myopia?
no,
It is here, behind retina.
behind it, so it's hypermetropia.
Hypermetropia, and also known
Hypermetropia
as
because
also
also known as long-sightedness.
long-sightedness.
Uh, List two causes of this defect: shortening of the eyeball
Hmm.
and
And focal length of the eye lens
focal
is
length of
too small.
eyelids is too small.
Wait, I think you didn't tell me reason why this is hypermetropia.
Ma'am, because the image is being formed behind the
The
retina
retina.
instead of on the
Huh.
retina.
And another reason you can give, near point for the person is farther away from the normal near point, that is 25 centimeter.
Yes, ma'am.
Huh. With the help of a diagram, show how this defect of vision is corrected. Which
So
lens
my
we will
stu-
use? Hmm. We will use which lens we will use?
we will use
Vex
convex to converge.
to converge
Converge the light rays on the retina.
on the retina. Very good. We will do 32 number question later, 32, 33, because these are long questions.
Yes, ma'am.
So it is impossible to understand. You remember, okay? In this, we have to do 32, 33, 34, 45.
Okay,
Some
ma'am.
huh, long questions we will discuss later. These are related to electricity. This one now 39 we have to solve. Wait a second. Yes, 39. Read the question 39.
Study the data given below showing the focal length of three concave mirrors A, B, and C and the respective distances of objects placed in front of the mirrors. In which one of the object in the above cases the mirror will form a diminished image of the object? Justify your answer.
So focal length of three concave mirrors. Concave mirrors are converging, diverging.
Converging, and the focal length is negative.
Focal length. This type is concave mirror. So focal length is given 20 centimeter and object distance is 45. It means where object is placed? Focal length 20 centimeter and 2f. It is 45. Oh, sorry. 2f will become 40. So object is placed here
It is beyond C.
beyond C. In second one,
Focal length is 15 and object distance is 30. So the object is exactly at C and the image will be of the same size.
next
Focal length is 30 centimeters and object is
20
placed in front beyond between P and F.
between P and F. Now, what is the question? In which one of the above case mirror will form a diminished image of the object? Justify your answer. Diminished image of the object. Here, when it is placed at 2f, then object and image has same
Same
size.
size.
When it is between F and P, then
It
image
will
is
be diminished.
no, it is virtual erect and
Right. It will be.
enlarged. That's why, if due to this condition, it is used by makeup artist, it is used by dentist.
Yes, ma'am.
So
So it's
in
case
first
one.
condition, okay.
Yes.
Next, oh sorry, first case,
List
huh.
List
Next
two properties of the image formed in case 2. Ma'am,
case
the
2
image is real and inverted because it is formed in front of the mirror and it
and
will be
also
of the same size.
same. Very good, very good. Third,
What is the nature and size of the image formed by mirror C?
hmm,
The nature of the image is real, virtual and erect, and
huh,
the image formed is enlarged.
enlarged. So here it is like we will prepare in this way. This one is concave mirror, straight line, it will go here, object, okay.
Yes, ma'am.
So when it goes straight, so after we are having this one between F and B, so after reflection it will go towards F and one will go like this, मतलब C से जाएगा ये, ऐसे समझना, okay.
Yes, ma'am.
So after meeting them behind the mirror, we will get enlarged image of object. That's one, that is virtual.
Yes, ma'am.
Now B part.
An object is placed at a distance of 18 centimeter from the pole of a concave mirror of focal length 12 centimeter.
Hmm. So 18 centimeter. It is object distance.
It
Concave
is
mirror.
beyond C.
हाँ, means
The image will be formed.
we have to solve it by formula. U will become minus 18 centimeter.
Yes, ma'am. F is also minus 12 centimeter.
F is minus 12 centimeter. So 1 upon F is equal to 1 upon V plus 1 upon U. Can you solve it?
Yes, ma'am. Just a second.
Start to solve it and let me know final answer.
Ma'am, V is minus 36.
Minus 36. Very good. So in front of the mirror at a distance of 36 centimeter from the pole of the mirror.
Yes, ma'am.
Okay, Thanya?
Yes, ma'am.
So that's all for today's class.